Okay, still in Chapter 6, we're going to look at an example of add polynomials, an example of subtract polynomials. To add polynomials, we simply drop the parentheses and collect like terms. All the signs remain the same. If you need to, you can write these in order. You can pick up the terms, like terms together. Some of you can do this without showing this work. You can just collect the terms without showing that, but I'm going to collect them for those of you that need to see that. That's a 5x squared plus a like 5x squared, a negative 5x, and a like positive 7x, a positive 30 and a like negative 53. And then put these all together. Like terms go together. Add the coefficients of the x squared term. 5 plus 5 is 10 x squared. Remember, we're adding like terms and the variable part stays like it was. Add the x terms here. Coefficients negative 5 plus 7 for plus 2 for the x term. And the constants positive 30, negative 53 for negative 23. Okay? Now, subtracting polynomials, we do have to change the signs of the terms that follow the subtraction. You can think of that as distributing the subtraction. So to drop these parentheses requires no work. Here, 2b to the 5th plus 6b squared minus 4. We're going to distribute this, so 6b to the 5th becomes negative 6b to the 5th. Negative 4b squared becomes positive 4b squared. Positive 18 becomes negative 18. Now this one becomes like the one where we added, because we've distributed the subtraction. Now we can collect like terms. 2b to the 5th with the like term negative 6b to the 5th plus 6b squared with the like term plus 4b squared minus 4 with the like term minus 18. Right, and then we combine the coefficients for the b to the 5th term, 2 minus 6 for minus 4 b to the 5th, plus 6 plus 4 for the like terms b squared is plus 10 b squared, minus 4 minus 18 for minus 22. Right, and no more like terms, so the subtraction is complete. Here the addition was complete. Here the subtraction is complete. Okay. Now let's take a look at multiplying polynomials. Notice that this is one term multiplied by 3 terms, a trinomial. So we need to distribute the multiplication. We need to distribute the 2 factor to all 3 terms here. Okay, so in order to remember what to do, you might do this right here. It's not necessary, but that would be 2x times the first term, 5x squared. And we're going to be multiplying again for another term. That's a positive 2x, so we would put plus 2x times the next term, negative 4x, plus 2x times the last term, which is 8. Alright, and now we perform the multiplication here. This is 2x times 5x squared, 2 times 5 for 10, x times x squared for x cubed. That's that product rule where we add the exponents when we multiply our same basis. Positive 2x times negative 4x, negative 8x squared. Positive 2x times 8, positive 16x. And no like terms to collect. Multiplication is carried out. This one we have 2 terms to multiply by 3 terms. Now you could distribute this 1 term at a time to each of these 3. But remember, in class we said that it's sometimes much more efficient if you have this many terms to stack these with the long polynomial on the top, 4x squared plus 4x plus 3, with the shorter one underneath 3x squared plus 3, and then multiply these as you would a 3-digit number times a 2-digit number. So we would start here and multiply 3 times 3, both positive, would give us positive 9. 3 times positive 4x gives us positive 12x. Positive 3 times 4x squared gives us positive 12x squared. Alright, notice when we multiplied by the 3, we started recording under the 3. Now we're going to move over and multiply by the 3x, so we'll start recording under the 3x. 3x times positive 3 is positive 9x. 3x times 4x is 12x squared. 3x, and that's positive, we should record that. 3x times 4x squared is 12x cubed. Okay, we've carried out all the multiplication, here, here, and here, and then here, here, and here. And now we're ready to total, which is combining like terms, and the like terms are stacked for us conveniently. So this column totals for positive 9, this column totals for positive 21x, this one totals for positive 24x squared, and this one is alone for 12x cubed. And now we have the result of our multiplication. Like terms are collected, no more like terms, so our result is this polynomial. Again, the last few we have to look at are patterns. Well, we may not have patterns that we might look at. So binomials, there are some patterns when we're multiplying binomials. When we have 2 terms times another 2 terms, we could stack these. So if we stack these, neither is longer than the other. We could rewrite this as 3b minus 2 times 4b plus 4, and multiply as we just did. This would give us negative 8 and positive 12b, and then multiply by the 4b times the negative 2, negative 8b, and positive 12b squared comes from this. And then we could total our columns, negative 8 plus 4b, 12b squared alone. That's one way to show your work, and remember another way is to FOIL, where we multiply the first times the first, that's the f in FOIL. 3b times 4b is 12b squared. O are the outside terms. 3b times positive 4 is positive 12b. I is for the inside terms. That's negative 2 times 4b, negative 8b. And L is for the last terms. Negative 2 times positive 4, negative 8. And then we need to collect like terms. These terms are like. 12b squared, these terms collect for positive 4b. Bring down your minus 8, and you see the result is the same whether you show your work with FOIL or whether you stack and multiply. The result is the same. So we'd call that pattern the FOIL pattern. This pattern, where we're multiplying 5a plus 4 times 5a minus 4, what we want to notice here is that this fits a pattern where the first terms are the same, the second terms are a sum and a difference, or a plus and a minus, but the number is the same. So we call this the product of the sum and difference of the same 2 terms. 5a matches 5a, 4 matches 4, 1 sum, 1 difference. And this fits the pattern where we multiply, or we square 5a. It turns into the difference of squares, the difference of 2 squares, and then we square the 4. And that would give us, remember this says 5 gets the square for 25, and a gets the square for a squared. And here 4 gets the square for 16. That's a result using your pattern that you memorized from difference of squares. If you forget that, remember you could also show it stacked. 5a plus 4 times 5a minus 4, multiplying those as we've done before. Negative 4 times 4 for negative 16, negative 4 times 5a for negative 20a. Multiply with your 5a times 4, positive 20a. 5a times 5a for positive 25a squared. Total your columns, negative 16. This column cancels for 0, adds for 0, and 25a squared comes down by itself. Notice whether you do your work this way or whether you remember the pattern, you get the same result, 25a squared minus 16. Alright, again, for this third one, there's a pattern. When you square a binomial, there is a pattern. Okay? When we square a binomial, it always comes out to fit this pattern, where we square the first term, that would be 6x, and then we end up with 2 of the middle terms that are the same. Okay, we'll prove this when we show it the long way later, but this would be plus 2 times 6x times 8, and then we square the last term. Okay, now by the pattern, this turns out to be square the 6 for 36, square the x for x squared, multiply 6x times 8 for 48x times 2 for plus 96x, and then square 8 for 64. Now remember, if you can't keep the pattern straight, you could stack these and multiply in our usual manner. That would be 6x plus 8 times 6x plus 8. Okay, we multiply 8 times 8 for 64, positive. 8 times 6x, notice that's 6x times 8 right here. That's what's happening here once. That's 48x. And then we're going to multiply by the 6x. 6x times 8, notice that's another one of these. That's another 48x. And 6x times 6x is 36x squared. And that totals for 64 here, 96x here, and 36x squared here. Okay? And again, notice whichever way you show your work, whether you show, this is a plus, sorry, if you show your work this way or if you do it by the pattern that you've memorized, you get the same result. Okay, now the reason that we really want to learn the patterns here, the reason we want to learn the patterns here for multiplying, although we don't need them, we can multiply another way, is that when we get to chapter 7 we'll be factoring, and that means we'll be going backwards, and so we'll be going from the result to the factored form. So if we remember the pattern going this direction, it will be much easier to recognize the pattern going in reverse. Okay, that's the motivation for learning those patterns. Okay, that completes your review for your exam 2, Math 0306. If you have not worked the practice exam in Pearson MyLab, I would do that. If you're not pleased with your grade on the practice exam, I would watch the review again. I would watch the review videos again and try again. A few times through that, and with a good grade on your practice exam, you should do very well on your exam 2. Good luck to you.